Welcome. Class number I have not noted down. Most probably 34, I think, part 2. Okay. But remember, most powerful class for finding support reactions for, there is no space to write here. You should write a beam for beams. Very, very important. It is beams. Okay. Later I will tell for frames and other structures. First we will cover the most critical part, that is beam, because now onwards this will repeatedly come up to end of structural analysis. Okay. Right here, a beam with one end hinged, other end roller. I told this is statically determinate beams, see last time. Or a beam which is just simply supported at both ends. Or a beam simply supported at two places with overhanging portion. Overhang will not decide whether determinate or indeterminate. Once again, two reactions. Or beam fixed at one end and free at the other end, that is called cantilever. Now, I will stick to a pattern. You should write everything. See, first write some statement you have to write. I will use red color for that one. See, for finding support reactions for statically determinate beams, make a note here, one note here. You write here, if it is statically indeterminate, it will be reduced to statically determinate state. Then once again, same thing will apply. Beams apply. See, apply. I will write black color. Some reason is there. I write black color. There's a reason for it. This is still red color. Apply, comma, apply the basic conditions of static equilibrium applicable. Right. For coplanar force system or coplanar beams, or beam is a coplanar force system, available, I write here, basic conditions of static equilibrium are sigma h equal to 0, sigma v equal to 0, and sigma m equal to 0. Okay, right here. Engineering mechanics you used to call sigma fx equal to 0, sigma fy equal to 0, and sigma m equal to 0. But for now onwards, for support reactions and full structural analysis will apply, and also for SFD BMD in strength of materials, sigma h0, sigma v0, sigma m0. Those who are serious, write once again. Algebraics, first of all, before that you consider one more thing. See, before applying basic conditions of static equilibrium, sketch the beam with action and reactions. Action means whatever loading given. See, for this question, these are all action, don't worry. Red color is reaction, red and green color is reaction. Green, I will tell you why. Sketch action and reaction. Support reactions are already explained to you. Pinned support or hinged support, two reactions, vertical reaction and horizontal reaction. Roller support reaction perpendicular to the plane. If the roller plane is horizontal, vertical reaction. If the roller plane is vertical, horizontal reaction. If roller plane is inclined, normal to the plane reaction. Fixed support has three reactions: horizontal reaction, vertical reaction, and also reacting moment, and in case of simple support, only vertical reaction. This all you write. Now, remember, when you, next one more statement you write. When you consider equilibrium, remember you have to consider action and reaction, or action with reaction. See, action with reaction will keep the force system in equilibrium, or our beam in equilibrium. A beam will be in equilibrium due to combined effect of action and reaction. Okay. Now, what about direction of reactions? See, in the notes I will write all these. Here I am dictating. What about direction of reactions? This I will explain little later, but briefly I will tell. It is completely your choice. For example, vertical reaction, you can consider it to be upward or downward. Horizontal reaction, you can consider to right side or left side. Reacting moment, either clockwise or anti-clockwise. What direction you consider reaction has no effect on the final answer. Finally, answer will come with the correct direction. Now, whenever you find support reactions using basic conditions of static equilibrium, use always sign convention. Sign convention is direction based. This all I am writing in the next round because very, very powerful. Sign conventions are, equilibrium conditions are direction based, like horizontal, sigma h, right side or left side, sigma v, upward or downward, moment, clockwise or anti-clockwise. You can take any sign convention. The sign convention considered by you has no effect on the answer. Whether you take, suppose when you make sigma v0, whether you take upward positive or downward positive, or when you make sigma h0, irrespective of whether you take right side positive or left side positive, or when you consider moment, algebraic sum of moments, whether clockwise positive or anti-clockwise positive, has no effect on the answer. When you find the reaction, always get it with sign. With sign. Very, very important. With sign. Now, that is plus minus. See, I wrote here plus plus. Actually, some people won't write plus. With sign. Now, what is the meaning of sign convention? Positive sign indicates that direction of reaction assumed or considered by you in the beginning is correct. Therefore, the reaction is in the same direction as you considered earlier or assumed earlier. Suppose you get negative sign for the reaction. It means the direction considered for the reaction or assumed for the reaction in the beginning when they are unknown is wrong. So the actual reaction will be in a direction opposite to the assumed direction. But remember, then it is without sign. See, if you get plus, means assumed direction correct. Enter the value with the same direction without sign. If you get negative, when you enter the reaction or consider the reaction in a direction opposite to the assumed, but again without sign. In the final answer, no plus minus. These all I have decided to upload one more class separately outside. I am starting one new, what you call is course, all basic requirement in structural engineering. There you can see plenty of things. There, one of the class is reserved for sign convention. And one more thing, I will upload it not right now when I go to SFT BMD, because when you go to SFT BMD, sign convention is not based on direction, it is based on nature. There, sign convention considered has got effect on the answer. In equilibrium, sign convention considered has no effect on the answer, but later when you find section forces, sign convention considered has effect on the answer. 1 minute, started raining here, I have to slightly pause. little earlier I told basic conditions of static equilibrium available are sigma h0, sigma v0, sigma m0. Now, remember, this is not a problem. Something I want to tell. Our first question is here. See, this is a master question. I put the title today most probably the very powerful question for support reaction for those who want to understand everything. Therefore, this is just a demo question. It is not a question. Do one thing. Write a small note. This will come once again later. See, one point load question will come in order later. But what I want is something I want to tell now. So, you consider a beam AB of length span 5 meter subjected to a vertical load of 10 kilonewton at 2 meter from here, the same point, a horizontal load of 6 kilonewton this side. We want to find support reaction for this beam. Okay, now, since it is only a demo question, I won't write anything, right? Let us consider reaction at rho B, which is horizontal roller plane, that is RB is the reaction here. Surely that RB is a vertical reaction VB. Okay, you should write. At A hinged support, you write one more sketch. Don't write that sketch. First sketch you write only that much. Second, after what all I tell you write and then write. Consider vertical reaction upwards, VA. Horizontal reaction right side. This all I will talk later. Okay, over. Red color reaction. Now do one thing. For some reason, I want horizontal reaction to be some other color. I will write green color. For some reason, I will tell you later. Anyway, color is used. Vertical reaction, I used red color. Horizontal reaction, I used green color. I should touch the beam. Okay, no problem. Okay. Now, apply the basic conditions of static equilibrium. I told you sigma h equal to 0, sigma v equal to 0, and sigma m equal to 0. Again, rain is troubling me. Okay, now I will apply first in the same order sigma h equal to 0, right side positive, everything I am explaining later. So plus HA minus 6 equal to 0, HA will come plus 6 kilonewton. Then sigma V equal to 0, I will take upward positive. Only forces plus VA plus VB minus 10, see that green color will not come, equal to 0. You will get VA plus VB, take that side, equal to plus 10. Call this as equation number 1. Because why? When you make sigma V0, both VA and VB will come. So, it will give an equation in terms of VA and VB. Now, take moment about A. Minus VB into 5. I will take clockwise positive. When you take moment about A, remember, VA into 0, HA also into 0, and 6 also into 0. All these three forces are passing through A, or when you take moment about any point, any unknown horizontal reaction or vertical reaction there will have 0 moment, but not for a couple. So you get minus C, finger, when I take moment about A, finger should be at A, minus VB into 5. Why minus? Anti-clockwise. Plus 10 into 2 equal to 0. I will get VB equal to plus 4 kilonewton. Take that side. Then, once I get VB equal to plus 4, substitute in 1, VA plus VB, just now I got plus 4, equal 10, VA, I got 6 kilonewton. This is what majority are doing. But I don't like this one. For beam problem, I don't like it. I will tell you why now. See, I don't like it. What we do is make a note. Suppose there is a beam, see, make a very powerful note. If a beam has got hinge support here, and imagine roller support is here. Imagine span is L. Now, see, here A, here B. Imagine there is a horizontal reaction, vertical reaction here VA, vertical reaction here VB, and a horizontal reaction HA. Here HA, okay, then. And also there will be some loading on the beam, okay, some loading is there on the beam. Now, when you apply sigma H equal to 0, you write here, you will get the value of HA. But most of the beam problem, HA does not come for shear force and bending moments. Not most, almost every beam, horizontal beam problem, horizontal reaction and horizontal forces will not come for shear force and bending moment. So this HA you are finding only because it is there. Now, our most important are red color one. See, our VA, you make a note, VA and VB are the most important. Most important. Okay, now, if I apply sigma H already, sigma H0 already over. I don't know why. Suddenly rain starts little more severely. So, okay, now you have to make a very important note. This I will remove now. Very powerful note, you have to write. This I will not explain each and every class, I will not explain. See, this all I will come later. Our most important reactions for structural analysis or SFD BMD in strength of materials and any chapter in strength of materials, and also for structural analysis later is VAVB. Remember, when you go to frames, HA also comes. When you go to arches, H will come. But for beams, for beam questions, most important is VAVB. So, instead of giving one hinge, one roller, it is traditional to simplify it. Usually, beams will be given like this. See, this way, simply supported beam, AB. Then, see, some loading will be there. There will be a vertical reaction here, VA, and vertical reaction VB here, span L. Both are same. See, here difference is HA is there, HA is not there. Anyway, this HA will come directly by sigma H equal to 0. So don't bother it. And for beams, we are not worried too much about this HA. If it is there, we will calculate. Our powerful is VAVB. Now, if you apply, you have to make a note now. If you apply sigma V0 first, see, you should write here. If you apply sigma V0 first, then in terms of VA and VB, you get equation number 1. One equation will come. Then you apply sigma M equal to 0. When you consider moment, always consider moment about a point where unknown is there. Now, very important, make a note. If I take moment about A, then VA into 0. So, I will write here now. This also I can remove. See? This also I can remove now. I want space. See here. If you write sigma M about A equal to 0, then, see, moment about A you are taking, then VA into 0, whereas VB into L. Sign is not required. So this is 0. So you will get the value of VB. Same way, if I take moment about B equal to 0, then moment about B, your VB into 0 and VA into L. So you will get this is 0. So you will get the value of what? You get the value of VA. Or make a note now. Take moment about A, you get VB. Take moment about B, you get VA. Or when you take moment about any a point at about any support, you get the vertical reaction at the other support. Other, very important, other support. Now, you write all these in details so that concept is fully clear. I don't know where I kept it here. Concept fully clear. Now write here. Therefore, instead of using sigma V0 first, instead of applying sigma V0 first, where you get equation, we will apply sigma M0 first. We'll apply sigma M0 first. Then you will always get other side reaction. Once again I will tell you, take moment about A, VA into 0, VB into L, VB will come. Take moment about B, VB into 0, VA into L, VA will come. Now, okay, then apply sigma V0. When you make sigma V0, VA, VB both will come, but by that time, one of the reactions is already known. So there is no forming of equation. You get step-by-step answer. See, instead of writing unnecessary equation one, then substituting back, so best is sigma M0, sigma V0. Lastly, we will apply, if required, sigma H0. Therefore, I will make a note here now. Now onwards, in my class, lastly, I use red color. Therefore, now onwards, that is right from now onwards. Now onwards, in my class, this is the best approach. Always first sigma M equal to 0. Algebraic sum of moment of the entire force system, that is considering action and reaction about any point equal to 0, but take moment about that point where there is an unknown vertical reaction. That is either about A or B. Don't by heart AB. Either about left hand or right hand. Not total left hand, overhang can be there. Either about left support or about right support. Then apply sigma V0. Lastly apply sigma H0. I will use green color because it is unwanted. Lastly apply sigma H equal to 0. Therefore, I will conclude now. Lastly, once again I will tell. Therefore, now onwards, we will apply basic conditions of static equilibrium for beams. I told for beams in following order. First, sigma M equal to 0. Algebraic sum of moment of the entire force system considering both action and reaction about any point equal to 0, but moment you consider about one of the supports. Okay, over. You get vertical reaction at other support. Over. Okay. Now you write. Next, sigma V equal to 0. Both the reactions will come, vertical reaction, but one of them is already known. You get the one more reaction. Lastly, if applicable, apply sigma H equal to 0. If applicable, apply sigma h equal to 0. So therefore, now onwards, our some disturbance is there. There are frequent interruptions because of rain. That's why sometimes I have to pause. Okay. Now anyway, continue. So remember, lastly apply sigma is 0. Therefore, as I told earlier, now onwards, when you find reactions, what you have to do is, I will put lastly here, final. I will not tell again and again now onwards. When we find support reactions for a beam, see, now onwards. When you have to find support reactions for a beam, consider action, you should write here, action and reaction. For you, whatever loading given is action. Reaction is from support. Assume direction for the reaction. I already told you 3-4 times what type of reactions will come. Okay, then apply basic conditions of static equilibrium in following order. First, always apply sigma m equal to 0 about any one of the supports. Preferably we consider about left support. Usually practice. Second one, apply sigma v0, and lastly, if applicable, apply try sigma h equal to 0. Over. Sufficient. Now you write note. Now one note you are write. Reactions we will start calculating in systematic order. See, like I will tell a beam subjected to central point load W, then there is a numerical value, some numerical, then eccentric load W, then numerical value, 2-point load, then you will get UDL, then UDL with point load, uniformly varying load. One by one in correct order we will start. That is from next class onwards. But today I want to make everything clear. So today's this loading is a mix-up loading. Right here, this mix-up loading is for some reason. So today's class is the most powerful example for finding support reaction. So question, I write here question. See, I will give sketch only directly. Question is find reactions at supports, supports A and B for beam shown in figure below. See, small sketch. Roller support, this is A, this is B, the length of beam is 12.5 meter. There is a point load here at 3 meter from here, an inclined point load of 100 kilonewton, which makes angle of 30 degrees. Then from left side, you go by a distance of 4.5 meter, then start an UDL, it's more required. Okay. See, one hinge, one roller. Okay, 12.5. Then UDL for a length of 5 meter, intensity is 20 kilonewton per meter. Then from right side, come by 2 meter, there is a point load of 60 kilonewton. Okay. Or If you want in words, I will tell. A beam is of length 12.5 meter. It has got a hinged support at the left end and roller support. I won't put ABC now. Roller support at the right end. Roller is in horizontal plane. An inclined force of 100 kN is acting towards the beam, making an angle of anti-clockwise 30-degree anti-clockwise with the positive x direction. See, with the or to the right side of the beam anti-clockwise, because or why otherwise, see, somebody may put this way. Then UDL of 20 kN per that is acting at 3 meter from left end. Then UDL of 20 kN per meter, 5 meter long, starts at 4.5 meter from right end. And one more point load, downward load of 60 kN at 2 meter from right end. This is the beam for which you have to find support reactions. Okay, now solution, systematic solution. I will tell you why this is very important. Okay, first, I will dictate something now. Consider equilibrium of the beam under the combined effect of action and reaction. Reactions, okay. Now, reactions are from support. Now do one thing. In the questionnaire here, you mark the point A, mark the point B. AB. Okay. If you want, draw one more sketch. Now write here. A is hinged support. I have dictated something, no space to write. A is hinged support. Hinged support will have two reactions. This all I explained. Vertical reaction and horizontal reaction. So, let VA be vertical reaction at A. We will assume the reaction to be vertically upwards. See here, vertically up. Let HA be horizontal reaction at A. We will assume the horizontal reaction to right side, blue color, sorry, is the green color, HA. Lastly, support B is on roller. How is the roller? Roller is in horizontal plane. So for a roller in horizontal plane, the reaction will be vertically up, not vertically up, perpendicular to the plane of the roller. Since the roller is horizontal here, see, reaction at B will be, this is B, the reaction will be perpendicular to the plane of the roller. It is like this, perpendicular. This is your reaction at B, RB. Of course, since it is vertical, we will call it VB. Okay, you write all these. Okay, now one statement you have to write. Now, sketch the beam neatly once again. See here, A, B. Mark both the supports. Okay, I shown the supports. Mark all the action. One thing forgotten now. Before you go further, one thing forgotten. I will tell here. I can write here. See. Before that, at this point, I will call C. A, B over. I will call the point as C. Right here. At C, there is an inclined load. So, that inclined load of 100 kilonewton, which makes an angle of 30 degree with horizontal, will resolve into component, one that point C, one vertically component down and horizontal component to left side. This will be 100 sin 30, 100 cos 30. 100 sin 30 is exactly 50 kilonewton. 100 cos 30 is 86.6025 kilonewton. Okay, I forgot to tell that one. That I have to check the camera. Okay, no problem. Okay, resolve the force. Little small I written because space problem. Okay, now come here. A is hinged support. See, I took reaction VA vertically up VA. Horizontal, I took right side HA. Reaction at B, I told reaction at B RB, since it is vertical, I will call VB. full length is 12.5 meter. At the point C, replace 100 kN by a vertical downward load of 50 kN and a horizontal left side load of 86.6025. Let me check that answer first of all. Somebody will comment later. 100 into cos 30. 86.6025, correct. 25 kilometer. Then, after some gap, there is a UDL will start. For what length? UDL will start for 5 meter. 5 meter length. Now, 1 minute. This is 3 meter. From here to here is 3. I want this distance. If it is 4.5, this is 3, this is 1.5. How? That I need not explain. Then 5 meter. Then from there 2 meter, 60 kilometer. Now from 12.5 subtract 3, subtract 1.5, so far 4.5, subtract 5, so far 9.5, subtract 2, so far 11.5, you will get that gap as 1 meter. Make everything neat and trick. Okay. Now start calculating. In correct order, start calculating. Okay. This all I will remove now. Okay, this I will remove now, not required, because I want this one for some purpose. Some writings are there. Okay. Start. Now, write the beam systematically. Now, consider equilibrium, considering both action and reaction. Apply. See what all I am dictating, you should write. Once this is over, those who are serious, write here. Once everything is over, write a statement. Now we will apply. See, you are right here. We will now we will apply the 3 basic conditions of static equilibrium in the following order. First, sigma m equal to 0, then sigma v equal to 0. Lastly, if applicable, yes, applicable here. So write sigma h equal to 0. This is the order we will use. We will apply in this order. See? We will apply, this is the order. This is order of application. When you take moment about any point. So take moment about any point, but not any point. You take moment about a point where unknown is there. So about A or B, right here. It is completely your choice. If you take moment about A, you are going to get a VB value first. If you take moment about B, see, if you take moment about A, VA into 0, you will get VB value. If you take moment about B, then VB into 0, you will get VA value. HA and this load will not come for moment calculation. Okay, now I will take moment about A. Now, those who want to systematically, write here, sigma m about A0, sign convention, I will take clockwise positive. If you want, write here. That is algebraic sum of moment of the entire force system considering both action and reaction about the point A equal to 0. Now, when you take moment about A, see here, VA into 0, HA into 0, 86.6025 also into 0. Usually it is customary not to write zeros, or if you are that much interested, you write here. How much? When you take moment about A, actually unwanted actually, see, VA into 0, then HA also into 0 and 86.6025 also into 0. So these are not required. You can skip that one. Skip it. So when you take moment about A, I told thousands of times for you, put your finger at A. Don't remove the finger. I always start from other side. Okay, start. VB into 12.5. These all I will not explain now. How to take moment, explain so much that if I explain, it will be insulting for people. So, VB into 12.5 is anti-clockwise, so minus. Then clockwise plus 50 into 3. This into, you know it, plus 20 into 5. See, 20 into 5 is the total load. See, 20 into 5 into 3 plus 1.5. 4.5 plus another 5 by 2. Lastly, plus 60 into, from 12.5 subtract 2, 10.5 equal to 0. See, minus VB is there. Take other side. These things all I won't waste time. Some people will do one thing, they will take this to other side, they will calculate all these, then they will write 12.5 VB equal to so and so, so VB equal to something by 12.5. What? High school class? No, you will get VB equal to plus 118.4 kilonewton. Class will dictate. We got positive sign for VB. That positive sign indicates that the direction assumed or considered by us, that is vertically up, is correct. Therefore, later when you enter the reaction or when you show the final reaction, you have to show VB as 100, no plus sign now, 118.4 kilonewton upward, over. Sigma V equal to 0, take upward positive. 1 minute. When you take sigma M equal to 0, moment, force into distance. When you make sigma V0, only forces, no into. So, plus VA, upward positive, plus VB, minus 50, only vertical forces, minus 50, minus 20 into 5 is the total load, minus 60 equal to 0, substitute VB equal to, how much you got? You got substitute VB equal to whatever you got here, 118.4, substitute here, simplify, take other side, VA will come plus 91.6 kilonewton. Okay, now, once again class, right, we got a positive sign for VA also. Positive sign indicates that the assumed direction VA is correct, so later your VA will be vertically upward by 91.6 kilonewton. Now, lastly, sigma H equal to 0, I'll take right side positive, green color, plus HA, only horizontal forces, minus 86.6025 equal to 0, you get the value of HA plus. Class, same thing. What direction we consider is correct. Therefore, you write all these and write the final answer if you want. See, therefore, final answer I am writing here now. Therefore, for the given beam, support reactions are as shown below. This is a hinged support. See, hinged support here. This is a roller support. Other things are not required. Okay. Then one inclined force given here, one UDL given here, one point load given here. This I took A and B. So the final reaction is VA, you took upward, positive came correct. Your VA equal to plus, no plus now, 91.6 kilonewton. VB, you took vertically up, correct. That also correct. Vertical reaction VB equal to 118.4 kilonewton. HA, we took right side, it came positive, therefore right side HA equal to 86.6025 kilonewton. This is the final answer for the support reactions. Okay. Now, right here, our question is over. One small note you make. Sometime you will be asked to find resultant reaction at A. Then it will be sum of the root of sum of the square of these two, and angle made by the resultant reaction with the horizontal will be tan inverse of vertical reaction by horizontal reaction. This I am not interested today. This I will tell you next class when I consider reaction in systematic order. There I will tell. Today my purpose is something else. Okay. Now, note you are right. one node. See right here, question is, solution is over. Solution is over. Now, one small note. Okay, this I remove now. Okay, I should have written it this side. I want some space here. One minute. Some space required for me. Okay. Done. Okay. Solution is over. Now, make a note. You should write a note here. When we apply sigma m equal to 0, see, when we apply sigma m equal to 0, that is the first condition. I told you you should write everything if you are serious. He told us that you should take moment about that point where unknowns are there. So either at A or B you took moment over. Now, just now we took sigma m about A0. Somebody may ask you, why A? Cannot you take B? Okay, you can take B. Therefore, I will solve once again now. Once again, I will solve. Okay, now start. Those who are serious, once again write the neat sketch. Or not required, right here. Sigma m about B equal to 0. Now, moment about B. This I have to change now. I will change it. Start. Take moment about B. Now finger should be at B, right? When you take moment about B, VB into 0, HA also into 0, even 86.6025 also into 0, start from there, VA into 12.5 clockwise. It is plus VA into 12.5. VA into 12.5. This color problem, okay. VA into 12.5 over, then minus anti-clockwise 50 into, from 12.5 subtract 3, 50 into 9.5. Again minus 20 into 5 is the total load into moment about B, 2 plus 1, 3 plus another half of 5, 5 by 2, lastly minus about B. First of all, I should not explain. 60 into 2 equal to 0. You are going to get the value of VA now. Last time when you took moment about A, we got VB. When you take moment about B, you are getting the value of VA now. Okay, I will calculate VA. See the calculation speed. Over. Plus 91.6 kilonewton. Sigma V0, take upward positive. Plus VA plus VB. I already explained earlier. Write it. Substituting VA equal to, how much you got? Plus 91.6 kilonewton. You will get VB equal to plus 118.4 kilonewton. Now, sigma is 0, write once again. Now write, if you want, same answer we got. So whether you take moment about A first or B first does not matter. But in the class, we will always usually take moment about left hand, habit. Okay, this is also over. You make a note. This purpose also over. Now, you write here. He wants to tell something else. He wants something else. Before that, I want to remove this. I want something else. Actually, over. When you take moment about A, when you apply sigma m equal to 0, right here, note, once again note. When you apply sigma m equal to 0, he told take moment about that point where unknowns are there. You know the reason, because that unknown into 0. Suppose someone will tell, sir, I want to take moment for some other point. Take it, so what? Take it. Where you want to take it? Sir, I want to take somewhere outside. Okay, where outside? Sir, somewhere here. outside here, okay. How much outside? Okay, this is HA, I'll do one thing, I don't want space now. This is HA, where? Somewhere here, okay. Here. How much? Point name. Some point, I will call the point as P1. Some new point P1. Okay, I'll do one thing now. P1 point, okay. Where? Some distance, tell me. Sir, 2 meter outside, left side, okay, 2 meter. This is my choice. Someone told, take moment about a point somewhere left side of the beam. Why? Just for fun. This is not for fun. This is to understand the concept, not for fun. Okay, take moment about P1. Now, sigma m about P1 equal to 0. Okay, when you take moment about P1, see here, V also will come, be careful. I should write it smaller now, equal to 0, clockwise positive. You get VA into 2 plus VA into 2, then VB into 12.5, not plus actually, it is anti-clockwise. See, when you take moment about P1, clockwise positive, anti-clockwise. So it is minus VA into 2, again minus VB into, actually this is asking unnecessary waste of time, but today not waste of time. VB into 2 plus another 12.5, 14.5. Okay, then further, anti-clockwise, plus 50 into 2 plus 3, 5. You should write how you got it. 50 into 5 plus 20 kilonewton per meter for 5 meter length into 2 plus 3, 5, 5 plus 1. My finger is still here only, see. 2 plus 3, 5, 5 plus 1.5, 6.5, 6.5 plus another half of 5. Then plus 60 into 2 plus 3, 5, 5 plus 5, 10, 10 plus 1, 11, 11 plus 1.5, 12.5, 12.5 equal to 0. This time what will happen is VA, VB both comes. This is the disadvantage. Never do it. You will get equation now. Therefore you will get, see, therefore you will get, therefore minus 2 VA minus 14.5 VB equal to, this all constant you calculate, take to other side. I am not calculated. Take to other side. It is 50 into 5 plus 20 into 5 into how much? 6.5 plus 2.5 plus 60 into 12.5 equal to 1900 plus 1900. Take other side, becomes minus 1900. This is called equation number 1. See, now you have to call this as equation number 1. Okay, now make, next make sigma V equal to 0. Sigma V equal to 0, upward positive. What you get? Only forces. Plus VA plus VB minus 50, it is same as last time, minus 20 into 5 is the total UDL, minus 60 equal to 0. Therefore you will get VA plus VB equal to 100, 150, 200, 210. Take minus that side, plus 210. This you call equation number 2. Okay, now do one thing. Solving 1 and 2, you get the value of VA and VB. Use calculator, equation mode, go there, solve. Solved. I got confidence. VA will come plus 91. I am responsible. If any calculation mistake, there correct it. 91.6 kilonewton. VB will come plus 118.4 kilonewton. Oh, right there. What answer we got earlier? Same. Lastly, sigma h equal to 0, you get HA. Finally, reactions are here. Okay. Now, okay, over, right here. Now, one more note. This is actually not time pass actually to understand correctly. Note, one more note. Someone told, sir, why you took the point left side of A? Just somebody told that way. Sir, I want a point right side, sir. Where you want? Sir, I want somewhere here. Okay, take it. P2. P2. It's a P1 gone now. P1, get out. P1 gone now. Okay, P2. I'll take the point P2 here. Okay. Somewhere here called P2. What distance you want? Some distance, tell me. Any distance, say 6 meter. Okay. 6 meter. Okay, take on 6 meter. Why 6? Just like that, some distance. Okay, now start. Sigma m about P2 equal to 0. P2, clockwise positive. See now, this all will change. I have to put little ink actually, 1 minute. I will pause and little ink I require. Okay, so what? Now solve once again. Start. Sigma m about P2 0. Start here. Finger here now. VA into 12.5 plus another 6 is 18.5. So it is clockwise now, not anti-clockwise. Remember about that point. These are clockwise, these are anti-clockwise. That much you can make out. So it is plus VA into, how much I told? 18.5 plus once again VB into 6. Now minus here 50 into 6 plus 2, 8 plus 1, 9, 9 plus 5, 14, 14 plus 1.5, 15.5. 15.5, correct? Huh? 15.5. Sorry, I not at load actually. See, I forgot to write load only. Minus 50 into 15.5 minus 20 into 5 is the total load into moment about this point. 6 plus 2 plus 3 is 9. 9 plus another half of 5. These all already explained thousands of times. Minus 60 into 2 plus 6, 8 equal to 0. When you simplify, you will get, what will you get? Equation will come now. Your equation will be, okay, I should remove the previous answer. 1 minute. I will remove the previous answer because I have to solve once again. Okay. The equation you will get is, therefore you will get 18.5 VA plus 6 VB equal to 50 into 50 into 15.5, 20 into 5 into bracket 9 plus 2.5 plus 60 into 8, all minus become that side positive, plus 2405y plus, see, this all minus, take that side, it becomes plus 2405. Call this as equation number 1. Equation number 1. Next, apply sigma V0, already there, plus VA plus VB minus all the load equal to 0. You get second equation, solve 1 and 2. VA will come, how much? Plus 91.6 kilonewton. And VB will come, MT calculator, plus 118.4 kilonewton. Sigma H0, you get H. Oh, now also answer tally. Now, right, lastly, someone will be laughing. Lastly, write a note. Okay. Someone told, okay sir, concepts are correct. So now I fully understood. Even if you take a point outside the beam for a moment, of course, procedure become lengthy, answer will come. Sir, how about a point inside, sir? Okay, done. Where? You want here? No, sir. I want somewhere in the UDL. Why? To struggle. Okay. Lastly, right. You will consider for sigma m equal to 0, instead of A, B or other point, we will take a new point called P3, where somewhere in the UDL. Okay, do one thing. I use a red color now. Imagine a point here, any point P3. Randomly write P3. The 5 meter, I'll write down now. There is a reason. The 5 I will write down here. Where? This 5 meters. Tell some distance. Sir, 2 meter. Sir, a fraction. Okay. 1.8 meter. Just like that. Y means no answer. 1.8. If that is 1.8, now I will tell this is 3.2. Nobody can tell, sir, take that as something else. No. This is 1.8. That is 3.2. Right here. Somebody want to check the answer. If you take moment about an intermediate point and he want to create more trouble by taking a point somewhere within the UDL. Okay, done. So what? Done. I'll remove the answer now. Start. I am not removing sigma v because it will become same. Sigma v I am not removing. See. Okay, start. Take moment about P3. Now your finger should be at P3. Okay, start. VA into 3 plus 1.5, 4.5. 4.5 plus 1.8, 5.4. This is too much depending on calculator problem. 4.5 plus 1.8. 4.5 plus 1.8 is 6.3. Okay. Other is 6.2 then. Okay. So answer is plus C. Sigma m about P3 equal to 0. Clockwise positive. So plus VA into moment about this point. 3 plus 4.5 plus 1.8 is 6.3 clockwise. Then minus now. See, now VA will produce clockwise moment. VB will produce anti-clockwise moment. Minus VB into, if it is 6.3, that is 6.2. Why? Or see here, 2 plus 1, 3. 3 plus 3.2, 6.2. Then, see, minus 50 into 1.5 plus 1.8, 3.3. Minus 50 into 3.3 minus, now see, UDL, a part of UDL is left side, another part is right side. Now see, I took one class earlier. How to take moment about an intermediate point. Now useful. So look this side. Only this much load. See here. This much load will be like this here. 20 into 1.8. 20 into 1.8 is the load into 1.8 by 2 is anti-clockwise, and that side plus the clockwise. 20 into 3.2, see somewhere here, one more load. 20 into 3.2 into 3.2 by 2 clockwise. Lastly, plus 60 into 3.1 is 4.2 equal to 0. You will get plus 6.3 VA minus 6.2 VB equal to, I will calculate. I don't know the answer. It is minus 50 into 3.3 minus 20 into 1.8 into 1.8 by 2 plus 20 into 3.2 into 3.2 by 2 plus 60 into 4.2 is 157. It comes to plus 157. Take other, see, it is coming plus 157. Take other side, it becomes minus 157 is your equation number 1. Because net comes positive. Okay, now equation 2, sigma V0, equation 2, solve 1 and 2. I will solve once again now using back side of the calculator. Plus, see here, 91.6. plus 91.6 kilonewton, and VB see number came here plus 118.4 kilonewton. Yes, therefore you make a note now. Always lastly, closing part of today's class. Today's class is a very concept based class. Do not skip. Study repeatedly 3-4 times. Your knowledge will improve. All doubts you are getting will be clarified. Okay. Now, what you are right? Best is sigma m0, sigma v0, if applicable, sigma h0. When you apply sigma m0, you consider moment about either this support or that support. Do not take some outside point or inside point. Unnecessary, what? It become lengthy. But whether you take, see, it irrespective, you can do one thing. You can take moment about a point somewhere there, 1,000 kilometers also. 1,000 kilometer or 1,000 crore kilometer, take moment. My guarantee, answer will come same. Okay, now I'll conclude this class now. Everything is over. Next class onwards, we will find support reactions, systematic order. See, like a beam with a central point load W, beam with eccentric load W, beam with the two loads W1, W2. Then corresponding numericals, full UDL, numerical UDL, half UDL, central portion UDL. Then combination of full UDL with point load and partial UDL with point load. Then uniformly varying load, all types, sometimes represented by right angle triangle, sometimes represented by isosceles triangle, sometimes represented by triangle in general, sometimes trapezium. Okay, then I will consider couples. These all I will start simply supported beam, one hinge, one roller, or simply supported beam, or simply supported with overhang, or cantilever beam. This all will come in order. I told you at least some 100 questions I want to solve, so that those who study from me and understand everything make a neat fair copy. See, this each and every question I am entering in the notes. In the notes I will write each and everything. In the class I will dictate sometimes. So those who study from me, they will tell support reaction is nothing for me now. For me is not me, for you. Okay, we will meet in the next class. Thank you.